Welcome, Prealgebra students. We're in lesson 60 today. We're going to talk about circles. So I just wanted to give you a little heads up because we're doing Saxon. Saxon is an honors math, not because it's any harder, just because it covers a little bit more than your typical math. And so because of that, what happens when you get to high school and you take Algebra 1 and Algebra 2, in 2 years, you take those 2 math classes and you get a third math credit. You get a geometry credit because along the way, it covers all the geometry you need for that credit. And it starts a little bit in pre-algebra, and this is part of that. So today we're talking about circles. Every point on the circle is the same distance from the center of the circle. We call that distance the radius. And the radius is defined as the distance from the center of the circle to the edge. And the edge of the circle is what we call the circumference. The circumference is the distance around the circle. Okay? Now, a chord is any line that is drawn from circumference to circumference or from the edge to the edge. So it could be from here to here or here to here. In fact, the diameter is a chord also. It is a chord that is drawn through the center of the circle. It cuts the circle exactly in half, and it is also the longest chord. Now, because it goes through the center of the circle, obviously half of the diameter is a radius, right? Because it's the distance from the edge to the center. Well, then you got from the center to the edge again. So that tells us that the radius is equal to the diameter cut in half or divided by 2. And that the diameter is equal to 2 times the radius. So those are some formulas that you need to write down. A long time ago, people way smarter than me, they thought that the circle was the perfect geometric figure. And it is, in nature, it is the strongest geometric figure. That is why you see trees that have a circular shape. That's why stems on flowers have a circular shape, because a circle is supported all the way around. It is the most flexible without breaking. And when you put pressure on any one point, it affects all the points supported at the same time. So it is the strongest natural shape in nature, or just in the world. It actually is. So they were, these ancient people, these really old folks, they were especially interested in the relationship between the diameter of the circle and the circumference of the circle. And they were able to figure out that there is this really long decimal number that has no end. They were, it never ends. But if you multiply the diameter or the radius twice times this number, that it will give you a really close approximation, like within just like a hair of being exact. So we use it. And that number is what they call pi. It just indicates the relationship between the diameter and the circumference. Because how are you going to measure the circumference? Unless you have a measuring tape that seamstresses use that they wrap around, or one of those that the health people use, they wrap it around your waist to tell you how big you are, right? Around your waist. Which I really don't like those measuring tapes, by the way. But you can't do that on paper, right? You can't do that with the earth. It's too big. So we have to have some type of formula that will do the math for us, because we can't just measure it. Pi actually stands for 3.141592654, and it goes on and on and on and on. It is a non-terminating, which means it doesn't end, non-repeating decimal. So that makes it, by definition, this is an irrational number. But it's really, really close. I mean, it's really close. So what we do is we do use it, but we round it, right? So we say that we are going to use the rounded version of this in our calculations. And that rounded version is 3.14. And we don't say that pi is equal to 3.14. We say that it is approximately equal to 3.14 because it is rounded. And anything that's rounded is approximately equal. You can't say it is equal because you don't have the entire number. And the entire number is what gives us a final or an accurate number. So we don't use that. We just use this approximation. But it works, so we stick with it. It's worked for, oh my goodness, thousands of years. We're going to keep using it. So we have a formula that calculates circumference in relationship to pi. And pi, this whole thing right here, it just means that if they took the diameter and they wrapped it around, like they started here, and they wrapped it around the circumference of the circle, it would wrap around 3 times with a little bit extra. And that extra is the 0.1415926. It's that decimal part. So 3 times and a little bit of extra, right? And that is the relationship between a circle and its diameter and its circumference. So we use this to calculate the circumference by saying that the diameter times pi is the circumference of the circle. You can also say, what we do is we sub in and we say that the circumference is also equal to 2 times the radius times pi. All right? Because we know that the diameter is also 2 times the radius. And a lot of times you won't have the diameter given to you. You'll just have the radius. But that's a quick calculation to do. All right? But keep in mind, it could be the diameter times pi. And a lot of times, you're going to get problems that give you the diameter of a circle is 10 foot. What is the circumference? Well, you just take that 10 and you stick it in front of pi, and it's 10 pi feet, right? So it's a lot easier when you know both of these, because then whatever situation you're given doesn't throw you for a loop and you don't have to think about it as hard. Now, the area of the circle, what's very interesting and what they were very, what's the word? They were very fascinated. That's the word I'm looking at. What they're fascinated by is that the area of the circle has the same relationship. It has the same relationship, but with the radius. And with the radius, it's not times, it's times it squared. Because when you think about it, this is just a length all the way around, right? It's just a length. It's one dimension. Distance is one dimension. But area is 2 dimensions. It's up and it's to the side, or it's got a height and it's got a length, right? So in looking at this circle, if we put another line here, we can actually see 4 quadrants of the circle. I know that's not exactly center, but it's close. And if we look at the circle, that's what these really smart people did a long time ago. They said, you know what? We could take this radius and we go from the top around to the edge. We could make a square like this, right? Let me make this work better. I'm going to line it up exactly with the circle. Edge to edge, right? So you could see that you could have 4 of these in a circle. 1, 2, 3, 4. And they figured out that mathematically that this part of the circle took up about .78.5% of the circle. About. Close. Well, if you have 4 of these, one here, one here, one here, and one here, right? And we multiply that times 4, right? Actually, I'm not going to multiply it by 4. I'm going to add it. I'm going to turn it into a decimal first. So if we take this percent and we turn it into a decimal, that decimal would be 0.785. Remember we talked about that. 78.5 over 100 would be 0.785. Now we're going to multiply this by 4 because there's 1, 2, 3, 4 quadrants of a circle. We can get 4 of these. And if you look, we have a radius here and a radius here. So it's radius times radius, just like you would do the area of a square, right? Side times side or length times height. That's what this is. So the area is radius square, right? We start with that. But then we have this 0.78 or the 78.5%, which is the actual part that is the circle. If we have 4 of those, watch what happens. Let me pull up my calculator. If I say 0.785, which is 78.5% in decimal format, times 4, what number do I get? I get pi. How cool is that, right? So 3.14. That's our approximate use here. So it's approximately 0.785. So it's approximately 3.14. So we can use pi. So we say R times pi. And that gives us all 4 of these at the same time. Mind officially blown. Now, we don't usually say it like this. Usually we say the area of the circle is pi r squared. It doesn't matter because they're all factors. We know that the commutative property multiplication says you can multiply in any order as long as it's all multiplication. It's going to be the same, right? 3 times 2 equals 2 times 6. Doesn't matter the order. What matters is that the elements remain the same. So that's what we're doing here. So keep in mind that the area formula is pi times r squared. Circumference is either diameter times pi or 2 times the radius times pi. And that for pi, when we want to calculate pi, we use 3.14. Pi is approximately equal to 3.14. All right. Let's do some problems, some example problems. And I think we really only have 2 problems. So we have a circle, right? 60.1. We have a circle and I'm going to just draw it instead of writing it out. I think that'd be so much cooler. All right, we have a circle and the radius of that circle is 5 centimeters. First, find the circumference and then find the area. All right, so the circumference of a circle is what? 2r times pi, right? Or 2 pi r. It doesn't matter what order we do it in. So if 5, so 2 times 5 centimeters, and we know that pi, we want to use 3.14 for pi, right? So we just multiply all that together. So we pull up our trusty calculator and we say 2 times 5 times 3.14 is 31.4. So 31.4, and we got to use this unit of measure, centimeters. That's the circumference. Area, if you remember area, it is pi times radius squared. So we put in 3.14 for pi, and then we put in 5 centimeters times 5 centimeters. All right, and we pull up our calculator, and we do the math on that. And we say 3.14 times 5 equals 78.5, but we have centimeters once, twice, so we have to put centimeters squared. Okay, centimeters 2 times, centimeters 2 times. If you don't have this exponent of 2 on your unit of measure, it is not area. If you have no exponent, then the exponent by default is 1. An invisible exponent is the exponent of 1 because it's there. It exists one time. You have to tell it that it's a different exponent to get a different result. So if you're going to write area, if you don't have that square on there, when I check it, it's wrong. I'll take off half a point. All right, that's actually all we have for lesson 60. So I will see you guys in lesson 61 next semester. This is the last lesson for this semester. Congratulations for getting through it, and good job with all your hard work. You should be proud. You've done a lot so far. See you guys next week.